First, I'd like to talk today about something known as an entity. In the database world, we can consider an entity to be something that is important, and we want to store information about this entity in the database. Conceptually, an entity should represent a single theme or a single business concept. For example, an employee might be an entity, a department might be an entity, a project might be an entity. Each of these is a single business concept about which we might want to track information on several different attributes. Using the employee example, we may want to track the employee's name, the department in which the employee works, the employee's telephone number, and so forth. We are going to be learning much more about entities when we explore our fourth topic, which will address the entity relationship model. Next, I'd like to talk about a concept known as a relation. A relation is a table. If you recall last time, we said that a table is essentially a two-dimensional grid which contains both rows and columns. A relation is a specific type of table. That is, in order for a table to qualify as a relation, the table must have certain characteristics. Let's see what these characteristics are. As you can see on your screen, several conditions must be met in order for a relation to qualify as a table. First, the rows in the table must contain information about instances of an entity. For example, if we are working with an employee relation, then each row in the table would represent a single employee. Columns in a relation are used to represent the attributes of the entity. Using our employee relation as an example, we may have several columns, such as an employee ID, or an employee name, or an employee telephone number. Values stored in the column are all going to be, in this example, employee ID numbers, employee names, or employee telephone numbers. Within the table, we have cells. A cell can be thought of as the intersection of a row and a column. In order for a table to qualify as a relation, the cells in the table can only hold a single value. That is, we are not allowed to store more than one value in the same cell. Further, all of the values within a specific column must be of the same data type. For example, if we create an employee ID column, we would specify its data type. We may, for example, use an integer data type for the employee ID. This rule says that all of the values which appear in that column then must be integers. Further, every column must have a unique name. This is necessary so that the database management system, are able to determine which column it is to which we are referring when we are making requests of the database. We could not, for example, create two columns in a table that were both called employee ID. It is possible to have multiple tables in a database, and we may have an employee ID in one table and an employee ID in another table, but we cannot have two columns within the same table that have the same name, such as employee ID. Another characteristic of a relation is that no two rows within the table can be identical. This does not mean that we are not allowed to have identical values within a column as we move from row to row, but rather this is saying that if we consider the row in its entirety, if we take all of the values in the row together, they cannot be identical to any other row in the table. And then the final two characteristics of a relation are that the order of the rows and the order of the columns cannot matter. Let's take a look at a sample relation. As we see, here we have a table which contains three columns: employee number, first name, and last name. The table also contains 4 rows. Each row in this table represents a single employee, and you will note that this table meets all of the characteristics that we discussed on the previous slide. So here we see a table with 3 columns: employee number, phone, and last name. But this table has several problems with it that mean it cannot qualify as a relation. The first problem is if we look at the values stored in the phone column for employee number 100. Here we have more than one value stored in this cell. In a relation, we are not allowed to store more than one value for an attribute within a given cell. Another problem with this table that disqualifies it from being a relation is that 2 of the rows are identical. We see that we have 2 rows which have employee number 100, a phone number of 215-7789, and a last name of Cadley. Remember that when all of the values for a row are considered together, there must be something that is unique about the row. No 2 rows can be identical to each other. If they are, the table does not qualify as a relation. What we can take from this example is an interesting point. That is, all relations are tables, but not all tables are relations. So that's an important point that you can remember. Now we're going to move on to a new topic, and this is a critically important topic for understanding the relational model. And that is the notion of keys. The general idea here is that a key is a column within a relation whose values are used to identify a row. Now, keys come in many different varieties. Some keys are unique, and some keys are non-unique. If a key is unique, what that means is that the values within the key column will all be unique within the entire table. For example, if we have an employee table which contains an employee ID, no 2 employees would be allowed to have the same ID. That would be a unique key. On the other hand, we have non-unique keys, and in non-unique keys, the idea is that the value of the column may be the same for more than one row within the table. Non-unique keys are generally used to categorize the rows within a table into groups. For example, if I have an employee table, one of the attributes might be department ID. So let's say that department ID number 2 is the accounting department. In this case, the department ID is a non-unique key within the employee table, and more than one employee may have a value of 2 for the department ID attribute. In the coming slides, we will take a look at many different types of database keys. But before I begin this exploration of keys, I wanted to present what I call Dan's topology of database keys. And I hope this will help you to understand the relationships among the different types of keys that we will discuss today. So you can see that all database keys can be subdivided into 2 major groups, unique or non-unique. Among the non-unique keys, we will discuss something called a foreign key. And among unique keys, you can see that there are several different types of unique keys: candidate keys, composite keys, primary keys, and surrogate keys. We will begin by examining a composite key. Remember that a composite key is a unique key, according to Dan's topology of database keys. And a composite key is called a composite key because it is composed of 2 or more columns. So that is, we combine the values of 2 or more columns together in order to get uniqueness. This is sometimes a challenging concept for people to understand initially, so I think the best way for us to explore the composite key is through an example. Let's imagine that we want to take a flight from Orange County to Washington, D.C. So we are going to purchase a ticket for this flight, and our flight will have a specific number. For example, we might be on flight number 34. Within the airline industry, a given airline might operate flight 34 once every day, and what that means to the airline is it's a flight from Orange County to Washington, D.C. So flight 34 is a flight from Orange County to Washington, D.C., and we make that flight once every day. Because flight 34 occurs every day, we cannot use that value, we cannot use flight 34 to uniquely identify a specific flight. That is, a flight with, a real airplane where a specific group of people get on board and fly from Orange County to Washington, D.C. In order to get uniqueness, we would need to combine that flight number with another piece of information. And one piece of information that we could use would be the date. Let's look at this table that's currently shown on your screen. As you can see, we have United Airlines Flight 36, and it exists in more than one location in the table, which means that the value of UA36 is not unique. However, if we combine UA36 with the date upon which that flight took place, those two values together are unique within the table. And this is true for all of the flights that are listed within this table. If we examine the flight number column, we can see that it's possible to have more than one flight with the same flight number. And if we examine the date column, we can see that it's possible to have more than one flight on the same date, but the combination of a flight number and a date is unique. We could therefore combine those two values together and use them as a composite key. Next, I would like to talk about a candidate key. A candidate key is called a candidate key because it has the potential to become something that we call a primary key. So just like in a presidential election, a candidate has the potential to become the president, in the database world, a candidate key has the potential to become the primary key. And if you remember Dan's topology of database keys, a candidate key was the second of our 4 types of unique keys. Since a candidate key has the potential to become a primary key, it's important for us to understand what a primary key is. As is currently shown on your slide, a primary key is chosen to be the main identifier for a relation. That is to say, the primary key is a unique key, and if we know the value of the primary key, then we will always be able to locate a specific single row within the table. For example, if I have an employee relation which contains a primary key column that is named employee ID, and I know that the employee ID in which I am interested is employee ID number 2, I should be able to uniquely identify a specific employee, just one employee, within that table. Let's see an example. Here we have a table with 3 columns, employee number, first name, and last name. In this table, we are using employee number as the primary key. That means that if I know a specific employee number, I should be able to locate a single specific employee within the table. For example, if I know that the employee number in which I am interested is employee number 107, there should only be one employee number 107 within this entire table, and I can then use that value to identify the employee. In this case, Shir Anavi. The next type of key that I would like to discuss is called a surrogate key. Now, a surrogate key is a unique key. It is typically a numeric value, like an integer, and it is intentionally added as a new column to a relation by the database designer for the purpose of serving as the primary key. Surrogate keys are often used when we do not have a column within the table that would naturally serve as a unique identifier, that is, as a primary key. On the previous example, we saw an employee table that contained an employee number. In that example, the employee number really had no meaning. The numbers were 100, 101, 102, and so forth. Those numbers had no meaning outside of the database. In that case, we might consider employee number to be a surrogate key. One of the common uses of surrogate keys is to avoid having to use a composite primary key in a table. Let's see an example. Here we see our airline flight table again. We have the flight number column and the date column, and we said in a previous example that if we combine those two values together, we can get uniqueness. But in this case, we've added an additional column, which I've called flight ID, and it's just another way of ensuring that each row is unique. I can uniquely identify each row simply by knowing the flight ID. Our next topic is to discuss relationships between tables, and here we will introduce a concept known as a foreign key. In the business world, it is very common for relationships to exist among business objects or business concepts. For example, employees can work in departments. In most businesses, each employee will work in just one department, but each department may contain many different employees. As another example, each project within a company may be assigned a project manager, but each project manager may simultaneously manage many different projects. So these business concepts, these business themes, are related to each other. In the database world, we establish relationships between the tables in our database by using matched pairs of values. To establish these relationships, we need to implement something called a foreign key. Put simply, a foreign key is a primary key from one table which is added or placed into another table for the purpose of linking the records in those tables together. The key value is called a foreign key in the table that receives the new column. So we create a new column in a table that is the primary key from another table. This new column is called the foreign key in the table which receives that column. Here we see an example. On the left we have a project table, which is just represented here by its attributes. So each project contains a project ID, a project name, and a manager ID. On the right we have a manager table, which contains two columns. They are the manager ID and the manager name. In this case, manager ID within the manager table is the primary key, and we have placed manager ID into the project table to serve as a foreign key. In this way, if we know the manager ID for a specific project, we can easily determine the name of the manager by using that ID to look inside the manager table. In this example, we have two tables, one named department and one named employee. Here we have added department ID, which was the primary key in the department table, into the employee table, where it will serve as a foreign key. In this way, if we know the department ID for a specific employee, we can follow that relationship over to the department table and use that information to determine the name of the department in which the employee works. One of the very useful capabilities that we gain by using these primary key, foreign key relationships is the ability to enforce something called referential integrity. Now, put simply, referential integrity means that each value of a foreign key must match a value of an existing primary key. And the database management system, in enforcing referential integrity, helps us to preserve the quality of the data in our database. For example, here we have a project table shown toward the top and a customer table shown toward the bottom. If I want to add a new project to the project table, in this case it's going to be project number 113, and I propose to link this new project to customer ID number 5, what referential integrity means is that the database will look in the customer table and will check to see whether a customer with customer ID number 5 actually exists. If customer ID number 5 does not actually exist in the customer table, then the database will not allow me to add the new project. Note here that customer ID in the project table is acting as a foreign key, whereas customer ID in the customer table at the bottom is the primary key. Also note that in the project table at the top, more than one row can have the same customer ID. In this case, we have 2 rows which have customer ID number 2. This simply means that these 2 projects, DB upgrade and new email server, are both associated with our second customer, whose name in this case is Priya. Customer ID is a foreign key, but as we can see, because more than one row can have the same value for the customer ID, this means that foreign keys are non-unique keys. If you recall Dan's topology of database keys, remember that we subdivided all database keys into 2 groups, unique and non-unique. And on the right side of your screen we can see that foreign keys are non-unique. Hopefully, based upon the previous example, you can understand why.